Hey guys, and we're going to talk about interest today. So, simple interest is the first one we're going to talk about. Simple interest is used when a loan is repaid in a lump sum, so the borrower has use of the full amount of money for the entire period of the loan. Simple interest is commonly used when we have personal loans, car loans, and mortgages. In all of these situations, the total amount of money is loaned to you up front. So the formula is I equals P times R times T. That means I is the amount of interest, P is the principal or the initial or starting value, R is the rate given as a percentage, and we must change the percent to a decimal when they give it to us, just like we've done in the past. T equals time, and that must be years to use this formula. So when time is given in months or days, we just convert it, and we will look at this on the examples below. So the first example says calculate the interest when time is given in years. So suppose that Nadine wants to borrow $900 for 1 year at 12% interest. Compute the interest. So we want to figure out, okay, well, what is her interest? So how much is she going to pay in interest is the question. So 12%, I have to start by changing that to a decimal. So we do that. We just take this decimal and we need to move it 2 places to the left. So that 12% becomes 0.12. So you can imagine the decimal is kind of here originally after the 12 to make it the number 12, and then we just move it 2 to the left. Okay, so then just in the formula, we need to fill it in. So I equals P, the principal amount was the 900, and then the R, the rate, is 0.12. We had to change it to the decimal. And then the time is, they said borrowed it, complete the interest. So calculate the interest time is given in years. So she wants to borrow it for 1 year. So 1 goes in for the time. That'll give me, then we just put it all into our calculator to find out the interest. So then I get the answer. The interest will be $108. The next question says, what happens to the amount of interest as the term or length of the loan increases? Well, if, as you can imagine, if more time goes in, this becomes higher, we're just going to end up paying more in interest. So I just wrote that as the term increases, the interest increases as well. It will always be cheaper in the long run to take a loan out for a shorter amount of time. The faster that you pay it off, the less interest you pay, so the better that is for the long run. Example 2 says calculate the interest when time is given in months. So we learned previously that in order to use the interest formula, time must be plugged in the years. Therefore, if it is given in months, we need to convert it. There are 12 months in a year, so to convert the months to a year, let's look at this example. We have, suppose Nadine borrowed $900 for only 8 months at 12% interest. What is the amount of interest? Well, 8 out of the 12 is the fraction. That's how much time it is in a year. So you can really just leave it as 8 over 12, 8 out of the 12 months. So as you can see here, I just put the same idea, the interest, the principal amount, the 900 times the rate, the 12%. Since it was the same as above, I just rewrote the 0.12. We moved that 2 places to the left, the decimal. And the time is 8 out of the 12 months. You could reduce this if you want, but you can also just leave it like this and put it in your graphing calculator, and you'll get an answer right from your calculator. It'll do order of operations for you and reduce the fraction and all of that, so you don't have to worry about any of that or making an error in any of that. When we do that, we get the interest that is $72. So the interest for that amount of time would only be $72. So you see how if we have less time, the loan is taken out for less time, the interest will be lower. Okay, this next example, we're going to look at when interest is calculated in days. This gets a little tricky because there are 2 types of interest when the time is given in days. Ordinary interest, that's only 360 days in a year. Exact interest is based on 365 days in a year. So let's use an example to look at why a bank might pretend that there are only 360 days in a year. Ordinary interest, 360 days. So we're going to look at that same example. Suppose that Nadine borrowed the $900 for 60 days at 12% interest. What is the amount of interest? So let's base this on 360 days. So we use the same formula. So I, the interest, is equal to the principal amount, again it's 900, times the rate, which is again 12%, so I'm going to change that to 0.12. And then what is the amount of time? Well, the fraction, if it's 60 days, but they're assuming it's out of 360, the fraction would be 60 out of 360, or 60 over 360. Okay, so then it's again just a job for our calculator, put it all in the way that you see it, and the interest is $18. Now let's talk about exact interest. So I'm going to take all this information because everything else is the same. She borrowed $900, 60 days, 12% interest. What is the amount if there's 365 days? So this same equation, we're going to change the denominator here to 365. So when we do that and we get that all in our calculator, we end up with a long decimal, so we're just going to round it to the nearest penny since we're talking about money. So it's $17.75. So you can see that even though it's not much in this situation, this value is lower than this value. So which method do you think banks prefer and why? Well, I think that they're going to prefer this one on the left, the ordinary interest, and that's because ordinary interest, because the amount of money paid back to the bank is higher. So the difference may not seem great to you. However, if we are discussing a business loan with your bank for hundreds of thousands of dollars, the difference would be great. Also, consider how many loans a bank gives each year. All those small amounts of money add up to be a higher profit at the long run. So ordinary interest is preferred by banks. Okay, next we're going to look at how we determine maturity value of a loan. So maturity value, M, is the full amount of money that must be repaid when a loan is due. That is the principal plus the interest. So determine the maturity value, figure the simple interest first, and then you figure out the maturity value. So the formula for the maturity value is the principal plus the interest. That makes sense. So how much we took out to begin with, and then add on all the interest that we're going to have to pay back. So this is how you can calculate how much you'll owe in the long run once your loan has all been paid back. So example 1, suppose that you borrow $1,825 at 12% interest for 1 year. What is the maturity value? So the steps. First, let's determine the interest, the simple interest, just like we did above. So that same formula. So that I equals PRT, and then we'll fill that in. I just wrote the formula because it's been a little bit since we've looked at the actual formula. We've been just filling in, so I just wanted you to see it one more time. So the principal amount is that $1,825, and then the rate, remember we have to change that to a decimal, so since it's the same one, the 12% changes to 0.12. Again, move the decimal place 2 to the left, and then the amount of time already is in years, so we're just going to multiply by 1. This will tell me what the interest is. Put it all in your calculator exactly the way you see it so that it can do order of operations and all that for you. So when we do that, we get the interest equals $219. So that helps us to find the maturity value because we're going to take the principal amount, the amount that we had originally took out for the loan, $1,825, and we're just going to add the interest. So this tells me at the end of my loan, I will owe this much altogether. So that $1,825 that I borrowed will get paid back to the bank as $2,044. So that just shows you exactly what you'll pay back at the end. So that's my answer for that example. So as we just found out, when we calculate the maturity value that we take out on a loan, we will pay back more than what we actually borrowed. So now we're going to look at compound interest. So compound interest occurs when interest is calculated on the original amount and any other previous interest. If we are compounding annually, it means we are adding on the previous interest one time per year. So look at these examples below. So when we calculated the simple interest, in year 1, we would just take, the original amount, the 1,000, times the 0.10, and that would tell us how much interest we'll pay for the year. So that's 100. Year 2, 1,000 times, again, that 0.10 is the same exact value. And the same will be true for year 3. So notice that each year you only pay the interest on the original amount, the $1,000. So the amount of interest you pay each year is the same regardless. The next one, though, if you take out a loan of $1,000 at 10% interest for 3 years, that's compounded annually. That means that 1,000 times the 0.10 will tell me the same value for the first year. However, that gets added on to the principal amount for the next year. So the value for year 2, the principal amount, the original, becomes 1,100. And when we multiply that by the 0.10, we get $110. Then that gets added on to the principal amount. So then that becomes the 1,210 as the original amount. Then we're going to multiply 1,210 by the 0.1 to get our interest for the year 3, which becomes this $121. So you can see that if it's compounded interest, we're going to end up paying more because this one only paid $300 total, but when we add these up, this becomes $331. So that will continue to increase as the years grow as well. So as I said, you will pay or earn more interest with compound interest. Compound interest is most often used for credit cards and investments or saving accounts. Watch out for loans with compound interest. It adds up very quickly. So to calculate compound interest, we will use the exponential growth formula. So our formula M equals P times 1 plus R to the T power. This is like exponential functions that you've learned in algebra. So M is your maturity value, the total amount that gets repaid, or the total amount in the account. P is your principal, the initial amount. R is the rate, it's given in a percent, so again we have to change it to a decimal. And T is your time, given in years. So all the same stuff, just using a new formula. Okay, so in order to find the total amount of interest, we need to subtract the principal from the maturity value. So that'll tell us just what the interest is, not what the total thing is. So when we use the formula, it gives us the total. We have to subtract if they're just asking for interest. So Ron needs $200 to start a new snow cone stand for the summer. He borrows money from the bank that charges 4% compounded interest per year. If Ron takes out the loan for 5 years, how much will he owe? So this one, how much will he owe? That's saying total. So he'll owe the $200 with the interest, so that's all being compounded together. So we don't have to subtract anything out for this question. Okay, so we use the formula M equals, then the initial amount, the 200, the 1 plus the rate, 4% change to a decimal that's after the 4, so then we move it 2 to the left, so it becomes 0.04, and then to the 5th power because it's 5 years. Then we can put this all in our calculator the way we see it, and it'll give us the maturity value. So when you put that in your calculator, you'll get this decimal, 243.3305805. Then we need to round this to the nearest penny. So remember, we look at the hundredths place here, the 0 next door tells us to leave it. So our answer is, then we get $243.33 as our answer. Okay, last example. Example 2, you want to put money into an investment. You plan on investing $10,000 and then not depositing or withdrawing any of the money after that. Money Growers, Inc. had an account that earned 3% interest per year compounded annually. Investments R Us pays simple interest of 4% per year. If you plan on withdrawing the money after 5 years, which is the smarter investment choice? In order to find this out, we need to calculate how much we'll have total after the 5 years. So we need to first do this for the Money Growers, Inc. Okay, so the Money Growers, Inc., we're going to find the maturity value by taking the original amount, so the $10,000, and putting it in place of the principal amount, and then the rate, so 1 plus, the growth for Money Growers was 3%, so I'm going to change 3% to 0.03 by moving it 2 places to the left, and then we know it's 5 years, so to the 5th power. That'll tell me how much money I would have. We can just put it all in our calculator, and we get an answer. So in our calculator, we get this long decimal, 11592.74074. So then we need to round to the nearest penny again because we're talking about money. So it's $11,592.74 because the 0 tells us to leave the decimal. Okay, so that's Money Growers, Inc., but now I need to do the same thing for the other Investments R Us so I can figure out which one is the better option. Okay, so for Investments R Us, we need to do the simple interest first. So the simple interest is calculated by taking the principal amount, so the $10,000, and then times the rate. In this case, it's 4%, so that's going to change to 0.04, and then the time, which is 5 years. So this will tell us how much simple interest is collected by putting it all in your calculator. So this tells me that I earned $2,000. But now to find the maturity value, remember that that was just the simple interest. So to find the maturity value, I need to take that and I need to add on the amount that I initially invested. So the maturity equals the $2,000 plus the $10,000. So that'll tell me that my total amount that I would get at the end would be $1,200. So now I have to answer the question. The question said, which one should I use? Well, I need to actually use Investments R Us because that total is higher for Investments R Us. The next question says, if you plan on withdrawing the money when you retire, let's say 30 years after you open the account, which is the smarter investment choice? So now I just need to do the same thing, but change the time to 30 years. Okay, so what I did was duplicate what I wrote up above, but only filled in what we know so far. So I have the $1,000 for the Money Growers, the $10,000, and then the 1.03, just like I had above, but now I changed the exponent to 30. So when I do that, I get 24272.62471. So now I need to round and put that as a money answer. So I have $24,272.62 because the 4 tells us to leave the 2 as it is. The next one, Investments R Us. So I wrote the 10,000 times the 0.04 times the 30 for the 30 years. Put that in our calculator and we get the 12,000. So I'm going to write the 12,000 here, but I'm going to add the 10,000 that I already invested, and we get 22,000. So which one would be better for 30 years? Money Growers Inc., because my total is higher than it is here. And this is, again, an investment, so I'm going to get this money out. Okay, so that's it for this video. Hopefully this helps you answer the questions using the examples that I've done for you in this video. Have a good night.